Hello. This time we're going to be talking about AQA's foundation tier paper on the practice set 1 paper 3, which is a calculator paper. So scientific calculators handy if you can, and we'll just dive in and have a look at question 1. By the way, before I do dive in, I will mention again, each individual link to questions is in both the description underneath the video and also in the comments. So if you want to click to individual questions straight away, if you want to skip to the questions you've struggled on and you're looking at this video after doing the test, feel free to do so you don't have to watch the whole thing if you don't want to. Anyway, let's have a look at question 1, as I said. Circle the decimal that has the same value as 4 over 5. Well, 4 over 5 is the same as 0.8. So I'll try and explain why that's the case. So 4/5 as a fraction, we can simply multiply both the top and bottom by 2 if we wanted, and 4/5 would therefore become 8 over 10, which is the same as, in decimal form, 0.8. The first digit after the decimal is the tenths column, and so that means 8/10, which should be 0.8. Now, the calculator will actually tell you this directly. If you were to simply just use a fraction button and do 4/5, press equals, and then press the S arrow D button to convert to a decimal form, it will tell you it's 0.8. So yeah, I can explain again why 4/5 is 0.8. We could even do decimal division using the bus stop method, but the calculator will make it easy for you, and it is 0.8. So let's move on to the second question. Question 2. Circle the word that describes the straight line PQ. Now what I've put into this box over here, hidden right now, is just something to help you revise, which is a diagram of the important parts of a circle which you need to remember for the exams. The examiner could ask you about any parts of this. So the circumference is the perimeter of the whole circle. The circumference is on the outside. An arc is a fraction of the circumference, in the same way that a sector is a slice taken from the middle and is a fraction of the complete area. Radius is from the middle going to the outside, and the diameter is the length all the way from one end to the other of the circle, passing through the middle. The diameter is double the radius. Now what we're interested here is this P line, P to Q line, and that's called a chord. A chord just joins any 2 points on the circumference with a straight line. A diameter is a special type of chord, you could say, because a diameter joins 2 points on the circumference too, but a chord is usually any other line apart from the diameter. So this one here is called a chord. So that's one we need to circle for question 2. Question 3. X equals 2,500 to the nearest hundred. What's the smallest possible value of x? And so this is a question asking us, what could x have been before it was rounded? And so if we were to round this value here to the nearest hundred, 2,400, this is the hundreds column here. In fact, I'll highlight the hundreds column in each number. That would round to 2,400 because next to the hundreds is a 4. We only round up if a number's 5 or more. This number here, 2,450, that one would round up to 2,500 because next to the 4 is a 5. Here, next to the hundreds is a 9, so that too would round up, as would the number at the end. That's only one off 2,500, in fact. But the question here is asking us for the smallest possible value of x, the smallest value it could have been before it was rounded up. And so since these end three would all round up to 2,500, we just need to pick the smallest one of these three. That's the biggest, that's the second biggest, but this is the smallest of the three that would round up to 2,500. And so the one we need to be circling is this value here, 2,450. Question 4. What is 1/4 of 5 hours? What I'm going to give you now, first of all, is the classic calculator question mistake. So, 1 hour equals 60 minutes. I'll just put this over here, just to one side for a second. To work out a quarter, we can divide by 4. So 1/4 of 5 hours, this is the classic calculator mistake now I'm doing. 1/4 of 5, 1/4 times 5, 1.25. So that must mean 1 hour, 25 minutes. That is the classic calculator question mistake. That would be wrong. Just to make it clear, it is not 1 hour, 25 minutes. 0.25 means 25%. Now remember, decimal is base 10. So here we'd have 100 hundredths before we get to the second unit, whereas in an hour we're talking about base 60. So decimals and time calculations can often be confused. What I would suggest, going back to what I said earlier, is converting into minutes. 1 hour is 60 minutes, so we can get to 5 hours by multiplying by 5. And so 60 multiplied by 5 would be 30. It wouldn't. What am I talking about? 300 minutes. Sorry about that, mind blank. Don't know what I was thinking. 5 hours is 300 minutes. As your trusty calculator will have no problem telling you, because 60 times 5 is 300. This is much safer doing it this way. And so 1/4 of 5 hours we can treat as 1/4 of 300 minutes. Because 5 hours is 300 minutes. But by converting to minutes first, it takes away a lot of the possible confusion. So if we work out 1/4 of 300 minutes, 1/4 of 300 will be 75 minutes. So an hour is 60 minutes. So if we take away 60 minutes, you'd have 15 minutes left. And so 75 minutes, which is 1/4 of 300 minutes, is the same as 1 hour, 15. If you're thinking, why is he spending so long explaining this? You'd be surprised how many times I've seen this mistake as a teacher. 1/4 of 300 minutes is 75 minutes, which is therefore the same as 1 hour, 15 minutes. So it's well worth being careful. This mark you could lose through carelessness could be the mark that changes your grade from a 4 to a 3, or from a 3 to a 4. Every single mark is crucial. So 1 hour, 15 minutes, and make no mistake, it is not 1 hour, 25. Question 5. Simplify 6w minus 5x minus 4w minus 2x. So for this one we've got two different things to be considering, two different terms, if you'd like. We've got terms involving w. I'm also going to highlight the signs before each term, because the signs before tells us whether to consider the term as a positive value or a negative value. Now the x's. So first we're looking at the w's. If it doesn't say if a number's positive or negative, we can safely assume it's positive. These 4 w's afterwards though are definitely minus. So 6 w's take away 4 w's would give us 2 w's at the end. Now the x's start off being minus, so minus 5x minus another 2x. Minus a minus makes a plus if the two minus signs are together, but with this one, the minus signs are separated by 5x. And so what we can think about this as being is we're taking away 5x, first of all, and then we're taking away another 2x's. How many x's have we taken away altogether? It's the same as taking away 7 x's. Minus 5 minus 2 is the same as taking away 7 altogether. And so simplifying the terms in w, we'd end up with 2w, and the terms in x would give us minus 7x. So our final answer is 2w minus 7x. We'd get 1 mark for getting 2w, 1 mark for obtaining minus 7x, 2 marks if we get both. Question 6. Beth uses these 4 cards to make 4-digit numbers. How many different 4-digit numbers can she make that are greater than 8,000? So clearly, if the numbers are going to be more than 8,000 in size, we're going to have to begin with an 8. And so I'm just going to grab this 8 here and think about what the biggest number is. The biggest number would be if your numbers are in descending order from smallest to biggest. So one number she could make, the biggest number, would be if you reversed all these digits, 8,542 is one possible number she could make. After that, we could have 8,500, and we could switch the order of the 4 and the 2 at the end. So we could have 8524. And so that's 2 different 4-digit numbers which are both bigger than 8,000. In fact, what you would have in total would be 4 plus 2. 4 here, 2 here. There'd be 6 numbers in total you could make that are bigger than 8,000. What I've got here is all the numbers that are bigger than 8,500. Now if we put the 4 first, we could have 8,452. Remember, each number can only be used once, so you can't use the same number more than once. So this one would be 8452. And then in the same way as I did before, we could have 84, and then just switch the order of the last 2 numbers. So instead of 52, we could have 25. And so that's all the combinations of 8 and 4. Before we did all the combinations of 8 and 5. The last couple of combinations is if we have 8 and then 2. So we could have 8,245. Or we could have 8,254, again if we just swap the order of the end 2 numbers. Now importantly, the question isn't really asking us what the numbers she can make are. She's just having to find how many numbers she can make that are bigger than 8,000. So actually the question isn't as complicated as I'm making it. I'm just trying to explain what these numbers would be. The main thing I'm trying to show you is there's 6 different numbers. This is the first number which is bigger than 8,000, and the second, third, fourth, fifth, and sixth. So there's actually 6 numbers she could make that are bigger than 8,000 using those 4 cards. So the answer to this one is 6 numbers. Question 7. A table shows a number of Year 11 students who were absent in 1 week. And there's a bar chart that he's made. And we have to write down 2 mistakes that have been made with this bar chart. Now, you could say, if you wanted, that the scale on the y-axis hadn't started from 0. So that would be accepted on the mark scheme. However, a lot of the time, not starting from 0 is okay. That's called a broken scale, which is something else altogether, which I'm not going to get into right now. And so it is possible to start a scale not from 0. Because of that, I'm going to go for 2 different mistakes, but I'm mentioning that first one so that if you do put down that the scale on the y-axis doesn't start from 0, just to let you know, that would be a mark for you. Now, the ones I'd go for is looking at the y-axis. It's not been labelled. So 11, 12, 13, 14, 15. These are the number of absences, but it's not been labelled. So mistake 1, I would say the y-axis hasn't been labelled. And the second mistake, with a bar chart, the gaps between the bars need to be all the same. In this case, they're not. If you have a look between the first and second bar, that's a gap of a square, which is fine. That too is a gap of a square. But these here are only half a square gaps. And so the gaps between each bar aren't the same, and they need to be for a bar chart to be drawn correctly. So the spaces between the bars aren't all the same, or words to that effect. They should be, if it's a decent enough bar chart. So those are the 2 mistakes I would be personally mentioning. Question 8. On the grid, draw a shape that is a reflection of shape A. There's lots and lots of different ones you could draw, which should get you for 1 mark. I'm just going to show you 2. Now, it does say to show your mirror line, and so what I'm going to do first of all is to do a mirror line going straight up like this, and one possible shape would be to reflect it in a vertical line, for example this line here. So if a shape's reflected, each point ends up being the same distance away from the mirror line what it is right now, but on the exact opposite side. So if we look here, this first bit is 2 squares away, so on the other side it'll be 2 squares away too. This is 4 squares away, this corner from the mirror line, so on the other side it'll again be 4 squares away. Just completing this idea, what you'd have is a shape completed like this. Now I'm not saying your mirror line has to be here, but if it were, that would be one possible valid option. I'm going to show you just one more option which would be allowed. So this way is if we're reflecting it, for example, in this blue line. I've chosen a different distance away from the shape. This one's only 1 square away. So if we were to reflect it this way, what we'd have, this would be 1 square away. The top edge, which is 1, 2, 3, 4 squares away, would be 4 squares away on the other side. 1, 2, 3, 4, like this. And that's just a case of joining up the points as best you can. And there you go. So importantly, just reflect once. Don't draw both of these shapes I've done here. I'm just showing you 2 possible options. Just do 1 reflection. Don't waste your time doing more than 1 reflection, whatever you do. So they're just 2 possible reflections you could do. to receive a mark. Part B, now we need to enlarge shape A. We're not given a centre of enlargement, so to be honest, where you do it does not matter. You can do this enlargement anywhere you'd like to. So we're not told what the scale factor is either. I think the safest, the easiest one to do would be scale factor 2. So scale factor 2 would be if all sides just get doubled in length. And so this top edge is 2 squares along. We could make it 4 squares along. 1, 2, 3, 4. If we multiply the top side by 2, we need to multiply all sides by the same scale factor. And so it's 3 centimeters high so far. So if we double that as well, 3 times 2, it'd become 6 high when it's been enlarged. Instead of being 1 square wide, this bit would now be 2 squares wide. And just completing the shape in the same way by multiplying the original lengths by 2. That's one possibility. That's where it's scale factor 2. So scale factor 2 has been drawn in black. Not that you'd have to label it, just draw it. I'll show you as well scale factor 3 in case you want to be a bit more adventurous. So scale factor 3, exactly the same idea as before, but this time we're going to multiply each side by 3. So 2 times 3 will become 6 along. 1, 2, 3, 4, 5, 6. Initially it was 3 squares high. 3 times 3 would be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 square in, multiply that by 3, it'd now be 3 squares wide. 2 squares up, multiply that by 3, it'd be 6. 2, 4, 6. And just complete the shape in the same way. Importantly with enlargements, each and every side has to be multiplied by exactly the same number as all the other sides. So scale factor 2, each and every side is doubled, or like I've done here in red, scale factor 3 is where each side is tripled in length. There'd even be enough space on the paper to do one which is scale factor 4, but I do think you'd be making it hard for the sake of it there. I think the easiest by far would be just to do a scale factor 2, or if you really wanted, you can do a scale factor 3 like I have done here. Question 9. We've got this offer for DVDs where they are £5 each, or buy 2, get 1 free. And so we're asked how many DVDs would you get for £35? So what I'm going to suggest we think about here is for each 2 you buy, you'd get 1 free. So I've done a little table here where we can consider on one side the DVDs you buy. So I'm going to just say this is bought DVDs. On the other side, we can think of this as being how many free DVDs you'd get. And so what it is you have to buy 2 to get 1 free. So for every 2 we buy, 1 DVD we get for free. Now, we're spending £35, and so how many £5 notes would there be in £35? Well, let's just count them up. 5, 10, 15, 20, 25, 30, 35. And so we'd actually only have to buy 7 DVDs, and for each 1, so for each 2 you buy, we get 1 for free. So this one, buy 2, get 1 free. This row here, buy 2, get 1 free again. That just leaves 1 left. Now this one wouldn't result in a free DVD, because that one would just be one final one bought on its own. And so in total, how many DVDs would you actually get? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then a final one with your final fiver would be 10 DVDs. So how many DVDs you'd get would be 10 altogether in total. Now for part B, we have a pictogram showing different DVDs sold according to genre, type of film. So it might be comedy, action, romance or sport. We're told the total number of DVDs is 260. No key's been given. Work out the number of sport DVDs. Well, one of the things with a pictogram is that each symbol represents the same amount each time. So let's see how many symbols of DVDs we've got. And so the top row, comedy, that's 5 pictures of DVDs, like 5 symbols as it were. Action, we've got 3.5. Romance, 2. And sport at the bottom, 2.5 symbols of DVDs. And so what we need to do is add up all these all together. And so if we get our calculator, 5 plus, I'm going to show you how to do a mixed number on your calculator now. So shift fraction button, 3.5. It might be easy just to say 3.5 to be honest, but just want to mention how to get mixed numbers on the calculator because it might be useful. Plus 2, and then plus 2.5 gives us a total number of 13 DVD pictures, 13 DVD images. So what we need to do next is to then work out that this is 13 DVDs in total, and to link that to how many DVDs that'll be representing in total. So 13 DVD images is worth 260 real, actual DVDs sold. And so what we need to do now is to work out what just one DVD picture would be worth, or how much it'd represent. Now to go from 13 down to 1, what can we divide 13 by to get 1? The answer is any number divided by itself would give us 1. But of course if we divide this side by 13 to keep the balance, we'd do the same to the 260. So 260 divided by 13 would come out to be 20. And so we've more or less got the question correct now. So each DVD picture is worth 20 DVDs. That's the key bit of information we need to solve this question now. So each DVD picture is worth 20. So that's worth 20, that's worth 20. They're all worth 20. But if you read the question, the only thing we're bothered about is the number of sport DVDs. Now the sport DVDs are here. So this one here represents 20. This one's 20. Now half a picture of a DVD will be half of 20, which will be 10. So altogether in total, 20 for the first picture, plus 20 DVDs for the second image, plus 10 for the last half an image, represents a total of 50 DVDs. We could do this with a direct calculation if you'd prefer. It's essentially 2.5 or 2.5 multiplied by 20, because each one is worth 20. But essentially the number of sport DVDs is going to be 50. Question 10, we've got a box A and box B, different numbers in each. Two of the numbers move from box A to box B. The total of the numbers in box B is now 4 times the total of the numbers in box A, and we're asked which two numbers move. It's a 2-mark question. If you were really unsure where to start, a trial and error approach would work, although it could be quite time consuming. What I would suggest would be to work out the grand total of what's in box A and box B. And so if we have a look at box A, the total of these numbers, so I'm just going to do a grand total. So box A first, 2 plus 3 plus 4 plus 6 plus 9. Then box B, we've got another 5 numbers to consider in box B. So we add to this 10 plus 1 plus 7 plus 8 plus 5. And let's see what that comes out to be. Let's add them all up. Just move this out of the way so we can see what we're doing. 2 plus 3 plus 4 plus 6 plus 9 plus 10 plus 1 plus 7 plus 8 and plus 5 is 55. So the grand total of all these numbers is 55. We're told in the question, by the way, that after the two numbers have moved, the total in box B becomes 4 times the total of the numbers in box A. And so as a ratio, we can think of this as the total in box A compared to the total in box B becomes 1 to 4. Now if we're sharing a total 55 into the ratio of 1 and 4, 1 lot in box A, 4 lots in box B, 1 plus 4 would be 5. So if we divide 55 into 5 equal shares, $11 is each lot. So each lot of numbers is worth 11. So box B, we're going to end up with 4 times what's in box A. So in box B, there'll be 4 times 11, a total of 44 in total. Well, so far, before any numbers move, the total in box B, the original total, 10 plus 1 plus 7 plus 8 plus 5, if you check with a calculator, that's a total of 31. And so for total, yes, total of 31, just double check it myself there. If that total is 31 but it rises to 44, then that's a gain of 13. From 31 to 44 is an increase of 13. And so that must mean the two numbers that move must be 9 and 4. Because 9 and 4 would give us a total of 13. So if 9 and 4 moved across and went here, that would then give a total of 44 in box B, with 11 left over in box A, which is, according to the question, what we'd have. 11.44 would be the same as saying that box B has 4 times the total of box A. So the two numbers that move must have been the 9 and the 4. And that's question 10 done. Question 11. A diagram shows a sequence of patterns And we have to work out for part A the number of circles in pattern 6. And so what it's always worth doing is just making a note of the number of circles in each pattern you've been given to see if you can spot a pattern within the pattern, if that makes sense. And so pattern number 1, we've got 3 circles. Pattern number 2 is 5 circles. Pattern number 3, 7. Pattern number 4, we've got 9. So hopefully we can see that the pattern number is increasing. The number of circles in each pattern number is going up in 2s. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. And so this pattern will continue going on and on. So we can just count the pattern for pattern number 5 and pattern number 6. Three, 5, 7, 9. The next one will be 11, and after 11 we'll have 13. So the pattern numbers, importantly, are going up in 2s. That's what we need to notice. And so, fairly straightforward, really. Pattern number 6 will have 13. So we just write that down for our answer to part A. Write in black though, not red. I've been a bit naughty there. Apologies. Part B, we have to complete the rule for the number of patterns. Number of circles, rather, in each pattern. And so, what was happening is, the patterns were increasing in 2s. So if I just write the pattern number here, we had 3, 5, 7, 9, 11, 13, 15, and so on and so on. Now, this is called an arithmetic progression, where the numbers are going up by the same amount each time. It's called an arithmetic progression. And what we can do for these is find the nth term. Although the question hasn't asked for the nth term, it relates directly to it. To find the nth term, first of all we need to find what the numbers are increasing by. And as I said for part A, the numbers are going up in 2s each time. Each number along, we're adding 2 to the previous number. So because it's going up in 2s, the number in front of the n is 2. So the nth term will relate to 2n somehow. The next thing is to think about what sequence you're taught from a very early age that goes up in 2s and compare that sequence to the one we have here. The sequence that goes up in 2s, from what you were hopefully taught from an early age, is the 2 times table. And so if we did the 2 times table underneath and compared the sequence we have here to the 2 times table, you should see that each and every number in our sequence, in this blue sequence, is higher than the 2 times table by 1. So it's like the 2 times table, only it's higher by 1 each time. And so that is the sequence of the number of circles in each pattern. It's 2n plus 1. And so in terms of part B, what we need, the number of circles is a pattern number, which is n, I've called it, multiplied by 2, and plus 1. So that links, as I say, to the nth term, because the number in front of the n was 2, hence the 2 there, plus an extra 1 on top, which is why I've put the plus 1 afterwards in here. In part C, which pattern number has 51 circles? And so we can use this formula for part B to help us. So I'm just going to call, let's see, the number of circles we're saying is 51. And so 51 equals, I'll call it pattern number n. Pattern number equals 2n plus 1. Now we have an equation to solve. So 51 equals 2n plus 1. We need to work out what n would equal so that the pattern number is 51 circles in it. So we need to get rid of this 1, take it to the other side, swap sign. The +1 changes to -1. 51 take away 1 is 50, and on the right hand side we're just left with 2n. We don't want 2n, we just want to know what n is. And so that 2 needs to move to the other side. What we're doing in effect is actually just halving each side. Half of 2n is 1n, half of 50 is 25. But as ever with algebra and solving equations, we work in reverse. And so it looks like that 2 here, which is multiplying the n, it looks like it's swapping side and swapping sign to a divide. And so the pattern number is 25. So the pattern that has it is pattern number 25. Now, if you weren't sure about that, there is another way which takes a bit longer, but which is absolutely fine. If we carried on this sequence I started above here, in blue, 3, 5, 7, 9, 11, 13. If you had a bit of stamina, you could just carry this on. Keep on adding 2 each time. It might take you a while, but eventually you'll get there. So if you have a bad time in the exam and you're really not sure what to do, just fall back on the obvious, because doing something is better than doing nothing. The only way to get no marks for sure is to skip a question out. So keep on adding 2. Not the most exciting way in the world, but it will work. Getting closer. 47, 49, finally, thank God, 51. So then you can see what pattern number 51 is. So start from that, that's pattern number 1, second number, third number, fourth, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25th. So it's the 25th number along. So again, that's a longer way, but would still get you there. The pattern number is pattern number 25. Question 12. In 2012, electricity cost 15 pence per unit, and a family used 3,729 units. So, 15 pence for each unit, and they used 3,729 units. So what we can do from this first part of the question is calculate what the total cost was for all those units. So 3,729 units, each one was 15 pence. So if you multiply that by 15 pence, just move this along so the calculator's not in the way. 3,729 multiplied by 15 would give us 55,935. But again, if we're using pence in the calculation, pence in means pence will come out. And so that's going to be in pence, which, if we like, we can convert to pounds. There's 100 pennies in £1, so the conversion factor is 100. So we can divide by 100, and what we'd get for this would be £559.35. Now you could just have typed in 15 pence in pounds if you wanted to. It doesn't really matter. Either or. 15 pence, you could have just said straight away that's 0.15 when written as a decimal. So that's the cost in 2012. We then need to compare that to the cost in 2013 when when we're told that the cost per unit goes up to 17 pence, and that the family now used 3,506 units. So 3,506 multiplied by 17 pence, again this will tell us the answer in pence. 3,506 multiplied by 17, 59602 pence yet again. So because the answer's in pounds, we want to change to pounds. So let's just change this to pounds yet again by doing the same thing, dividing by 100, because 100 pence makes £1. We would find that the total in 2013 for the electricity is 596.02. So now we've got a value for 2013 and a value for 2012. The question is asking us how much more did the family pay in 2013. So how much more just means we need to find the difference between 2012 and 2013. And so what we do is just subtract one from the other. So 596.02 minus 559.35. So this one here, subtract £559.35, that comes to £36.67. So that's how much more expensive, well actually no, that's how much more they spent in 2013 compared to 2012, is what I should say. £36.67. Question 13, we need to work out the area of shape A as a ratio to the area of shape B, and what's more, we need to give our answer in its simplest form. So for shape A, what we could do is split this into separate rectangles by just taking one line and dividing straight down. And so if we were to do that, we'd be able to see that this rectangle here is 2 squares along, and it's 1, 2, 3, 4, 5, 6, 7, 8 squares wide, if you'd like. So 2 times 8 is 16. You could, if you wanted to, just count the squares actually, whichever way works best for you. And the other one of the side is 2 wide by 4. 2 by 4 is 8. So for shape A, the total area for shape A is 16 plus 8, which is 24. So the area of shape A is 24. Now we need to compare that to shape B. So for shape B, it's a triangle. We need to remember that the area of a triangle is the base multiplied by the height divided by 2. Important, but we divide by 2 when working out the area of a triangle. So the base is 4 squares along, and the height is 3 squares. So the base times height is 4 multiplied by 3, which is 12. Then divide by 2, we'd get 6. So for this triangle, the area is 6. So the ratio of the area of shape A to shape B is 24.6. Now what we can do is simplify this down I'll show you with a calculator in a second how you can think of it. We can divide both of these numbers by 6. And so if we divide the 24 by 6 and the 6 by 6, what we'd get is a final simplified ratio of 4 to 1. And that gives us our final answer. The area of shape A to the area of shape B as a ratio is 4 to 1. Now a calculator can simplify ratios for you if you think about ratios as a fraction. Not because ratios and fractions are the same, but they do simplify in exactly the same way. And so what you need to do to use the fraction button to its full extent is put the smaller number of a ratio in first, on top of a fraction. On the bottom, put the bigger number. So imagine this is 6.24, press equals, then get 1.4. But then obviously we need to switch the order around so that that 4 in each of them actually comes first, and the 1 actually came last. So do be careful when using fractions to simplify down ratios on your calculator, because they aren't exactly the same as I say. But with practice you will see how they link, and it can make it easier just to double check your answer. Question 14. Work out 258% of 6,300. So percentage means out of 100. So what I'd suggest is to write the percentage as a fraction out of 100. There are many ways of doing percentages. Your teacher might explain it a different way to me. That's fine, as long as we agree in a second on what the final answers should be, and as long as you understand it, of course. So that's 258% of 6,300. And so what we can do now is just bash these numbers into our calculator, or if you want to be nice to your calculator, you can gently type them in. 258 out of 100 multiplied by 6,300. And that tells us it's 16,254. And that's all we need to do for question 14. Once you've revised your percentages and finding percentages of amounts, that's relatively speaking straightforward. So just to recap, the answer is 16,254. Question 15. We're told that A is 3 and B is 5. Tick whether each statement is true or false. Well, AB means A multiplied by B. If you've got two things in algebra just next to each other with no mathematical symbol, it just means one thing multiplied by the other. So AB means A multiplied by B. And so if A is 3, that will mean 3 multiplied by B. So if B is 5, that'll mean 3 multiplied by 5. And 3 times 5, I'm sure you probably know, is 15. So first of all, this one is actually false, because AB would actually be 15. And the second one here, 2b squared equals 100, well, does it? Let's see. 2b squared, there's nothing in between the 2 and the b, so yet again that will mean there's an invisible multiplication sign between them. So this means 2 multiplied by b squared. So if b is 5, that will mean 2 multiplied by 5 squared. Because, as I say, b is 5. And so 2 multiplied by 5 squared, this is a BIDMAS question. We've not got any brackets, no indices, no dividing, no multiplying, no adding, no subtracting. I did make a mistake there. I can assure you it was a deliberate mistake because I'm never, ever, ever wrong. Honest. There are indices here because the indice is the power. And so what we need to do first of all is work out the power of 5 because the indices, I, which stands for powers, comes before multiplication. So we multiply after working out the power. So this would be 2 multiplied by 5 squared, which is 25. And 2 times 25 is 50. So again, this one's also false because 2b squared would be 50. Now we've got a luxury of having a calculator, so with a calculator, if it's a good scientific calculator like the Casio tends to be, we can just type it in as it appears. So 2 multiplied by 5 squared, look, it's 50. So without having to stress about BIDMAS, I'm just explaining why the answer is 50. You could just type in on your calculator just to reassure yourself that it would be 50 and not 100. So don't be thinking that because one's false it will be true. Think it through. In fact, both of these ones, we need to tick false for each. 16. I've got a pie chart showing some information about the share of votes for candidates in an election. It says the angle for Mrs. Wood would be 24 degrees more than the angle for Mrs. Patel. And we're told there's 5,220 votes in total. Work out the number of votes for Mrs. Patel. So, Mrs. Patel is who we're interested in here. I'm going to show you 2 different ways for this one. The second way is going to be trial and improvement. The first way I'm just going to use algebra to try and show you what we can do. So, we're interested in Mrs. Patel's votes, as I say. And so, what I'm going to do is we'll call Mrs. Patel P. So it says here that the angle for Mrs. Wood would be 24 degrees more than the angle for Mrs. Patel. And so if we say Mrs. Patel's angle is P, then the angle for Mrs. Wood, if it's 24 degrees more, would be 24 plus P. So what we'd have altogether is an angle in the pie chart for Mrs. Patel, an angle for Mrs. Wood, which is 24 degrees more than P, which we can say is 24 plus P, plus of course, let's not forget Mr. Smith, whose angle is 64 degrees. Now, a pie chart consists of 360 degrees, and so if we add up all these angles in the pie chart, the sector angles, 64 plus P, plus vote for Mrs. Wood, which was 24 plus P, all this will have to come to 360 exactly, because that's what angles in a pie chart would add up to. So just colour coding here, that's Mr. Smith, Mrs. Patel, and then Mrs. Wood, who is 24 degrees more than Mrs. Patel. So what we can do here is simplify this. So P plus P, we have 2 P's, and 64 for Mr. Smith, 24 here relating to Mrs. Wood. 64 plus 24 would be 88. So 2P plus 88 equals 360. This is an equation we can solve. So we want to have P on its own, so we can move this 88 to the other side. If we swap side, we swap sign. This plus 88 will become minus 88. And so on the other side, what it'll be is 360 minus 88, which is 272. And so that says that 2p, 2 lots of the angle for Mrs. Patel, would be 272. So we can work out the angle for Mrs. Patel by dividing both sides by 2. That 2 is multiplying the p. So in terms of thinking of it as swapping side and swapping sign, opposite of multiplying is dividing. So the angle for Mrs. Patel will be 272 divided by 2, which will be 136 degrees. So the angle for Mrs. Patel is 136 degrees. Whoops, I said Mrs. Patel was highlighted in yellow. And so altogether, we're told that there's 5,222 votes. Now, because we know now that the angle for Mrs. Patel is 136, we can put this into a calculation. The fraction of the votes Mrs. Patel got will be 136 degrees out of a total of the pie chart, which is 360 degrees. So she would receive that fraction of the total votes, which is 5,220. And so we can just do this calculation directly to arrive at our final answer for the number of votes Mrs. Patel got. So she gets 136 360ths of the 5,220 votes altogether, which is 1,972 votes. So that's quite algebra heavy, that method. But I would say that's most recommended, in my opinion. I did say I'm going to mention a different method, which is trial and improvement based. So just use this with a slight bit of caution. So same question, different method. Now in an exam, if it says a diagram isn't drawn accurately, always pay attention to that. However, usually the diagram won't be so badly drawn that the diagram's drawn really, really inaccurately. So they're normally going to be not too inaccurate anyway. That's almost just a disclaimer. That's saying to you that if you measure it and get it wrong, don't blame us. So although we can take this with a pinch of salt, if you're really not sure where to start, you can actually do far worse than measuring the diagram anyway, just to get a rough idea of what the size of the angle may be. And so if you were to get a protractor and actually measure the angle for Mrs. Patel, so put the centerpiece of the protractor over where the angles converge, and measure from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130-ish. It's between 130 and 140. And so we know the angle for Mrs. Patel. I mean, that looks to be about 135 to me, but let's go with 130 for now. So if we go for 130, we've got a starting point. So now what we can do is think about doing this systematically as a table. So I said the angle for Mrs. Patel may be roughly 130. Now, if you've seen the first part of this question, I know that you know what the angle actually is. So I'm just saying this is an alternate reality where we're trying a different approach. Let's say we didn't know what the angle for Mrs. Patel was. 130 is our first guess. Now, based on what it says in the question, the angle for Mr. Smith will always be 64 degrees. And here it says that the angle for Mrs. Wood will be 24 degrees more. So the angle for Mrs. Wood will always be the angle for Mrs. Patel plus an extra 24 degrees on top. So 130 plus 24 will be 154. Now, all of these angles, the three angles in the pie chart, they've got to add up to 360. So what we can do is we can see if these do. 64 plus 130 plus 154 is 348. So we're not far off, are we? But that's a bit too low, because obviously it needs to be 360. So if that was too low, we need to make the angle for Mrs. Patel a bit bigger. So we could try 131. The angle for Mr. Smith is 64 because it says. So for definite, we know the angle for Mr. Smith is 64. So that's never going to change. What is changing is our estimate. So let's try 131. 24 bigger than that would be 155. So let's try this. 64 plus 131 plus 155, 350. That's still a bit too low. It's going higher, it's going to be right direction, but it's still too low. So maybe make the angle for Mrs. Patel a little bit bigger. Maybe it's 133. Now if the angle for Mrs. Patel is 133, 24 degrees bigger than 133 would be 157. So let's try that. $354. Again, it's too low. Now this trial and improvement method I'm mentioning, it really is a final scenario, because also we're relying on the number here not being an awkward decimal. So there is always going to be an element of chance with trial and improvement, but I'm just showing you here so that you can always at least have something to try if you're stuck. So anyway, 133 degrees was still a bit too low. Let's make it a bit bigger, maybe 135. If that's 135, add 24 for Mrs. Wood's angle, 159. Let's try these. 64 plus 135 plus 159, 358. Mega close now, but still a tiny bit too low. So because we're too low, we still need to make it a tiny bit bigger. So if we were to try 136, and 24 bigger than 136 is 160, eventually if you tried those, you would get that these add up to 360 degrees, which is exactly what they should do. So that works. And so the angle for Mrs. Patel must therefore be 136 degrees. So Mrs. Patel gets 136 360ths. That's the fraction of votes she would get. And in the same way as before, Mr. Patel must get this fraction of the total votes, which, just to mention again, is 5,220. So if you work out this fraction of 5,220, again, you would get the answer we need just via a completely different method. (1972). So again, Mrs. Patel will get 1972 votes. Now, don't get me wrong here, I'm not saying you should be doing trial and improvement for every question and just trying to guess your way to the right answer all the time. What I am trying to say is, if you're completely stuck, do try to remember different alternative approaches which are better than trying nothing at all. And so in this case, trial and improvement would get you there eventually. Question 17. Got white paint and red paint mixed together in the ratio 2 to 3. And we need to draw a graph that can be used to work out the amount of red paint needed given the amount of white. And we're told the graph must show up to 10 litres of white paint. So what it says here is that because red paint is mentioned first, the 2 represents red, and the white is represented by the 3. Oh dear me, that's terrible. No, white paint is mentioned first. Apologies. I always leave in my mistakes with these questions because I want to just show you that, you know, maths teachers are far from perfect. Not that you needed telling that, but you know, it's not a case of having to be perfect. It's just a case of reading the question as best you can and taking it from there. And so white paint is 2, red paint is represented by the 3. And so for 2 lots of white, we'd need 3 lots of red. But of course, if you look here, there's no scale. What I'd suggest is to keep the scale the same and have each square, each big square, equal to 1 litre of red. So if we just go up the axis, 1 by 1, (14, 15, 16). It does say the graph must show up to 10 litres of white paint. So this is red paint in litres. So if we had 2 litres of white, we'd mix that with 3 litres of red. So this point here would go there. And what we can do is keep building up in the same way. So we need to go up to 10 litres of white paint. So what I'd suggest is, if we take this ratio here, we've got white and red in the ratio 2 and 3. If we need 10 litres of white paint, just think, how can we go from 2 to 10? What could we multiply 2 by to get 10? The answer is we could multiply by 5. But again, if we multiply one side by 5, we'd have to do the same to the other side. So 3 times 5 would be 15. So if we did have 10 litres of white, that would be mixed with 15 litres of red. So what we'd have here is a straight line graph going through this point, and it would be going through the first point all the way, in fact, through the origin. And so that graph shows us how the white relates to the red. And part B, if I just quickly copy down the graph we had before, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 15 here. I know I should label the axis, but on your actual exam, you could just use the actual graph back here. So this is how much red paint needs to be mixed with 9 litres of white paint. So if we just find whereabouts 9 litres of white paint is, 9 litres of white is here. And so if we now just take this point and follow it up and along on our graph, we'd hit the line here. So go straight across, and what we'd see, slightly on the low side of that, is it would be between 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's between 13 and 14. Now that's only because my graph isn't quite perfect. It looks closer to 13 than 14, but actually it would be exactly 13.5. I'll try and explain why now. So the ratio of white to red, as before, was 2.3. And so if we're using 9 litres of white, again, just be thinking, how much bigger is 9 compared to 2? We can do this as a direct calculation by doing 2's into 9. 9 divided by 2, which should be 4.5. And so what we're saying here is that this number here is 4.5 times as much as 2. And so we can do the same with red. This number multiplied by 4.5 so 4.5 multiplied by 3 will be 13.5. And so even if a question does imply you can use a graph, if you can, it's always worth just seeing if you can just check your answer using a numerical method or calculation. But in this case, it would be 13.5. So between 13 and 14, 13.5. So question 18, got a perimeter of an isosceles triangle, which is 25 centimetres, and we're told the length of each side is a prime number. So what we could do first of all is just recap what prime numbers are. So prime numbers are numbers which only have exactly 2 different factors. So if it can only be divided by 2 different things, it's self and 1. Our first prime number is 2. 1 isn't a prime because 1 can only be divided by one number, 1. So first prime is 2, which can be divided by 1 and 2. Next one's 3, which can be divided by 1 and 3. 4 isn't. Next prime is 5 and 7. 9 isn't because 9 can be divided by 3 as well as itself and 1. Next one is 11. Then 13. 15 isn't because we can divide it by 3 and 5. 17, however, is, as is 19. 21 isn't because we can divide it by 3 and 7. And then 23. So these are all the primes up to 25. 25 itself wouldn't be a prime because we can divide it by 5. So a triangle, obviously, is going to have 3 different sides. But if we're talking about an isosceles triangle means 2 sides that will be the same. Not all sides are the same. If all sides are the same, it'd be equilateral. Isosceles means where 2 sides only are the same. And so what we need to be thinking about is combinations of these numbers which would add up to 25, where each one is going to be a prime number. So what we could we have 2, 2, and 21? No, we couldn't, because 21 isn't in the list. Could we have 3 twice? Maybe we could have 3 and 3. Now 3 and 3 would be 6, but then 6 through 1.5 to be 19. Now it's tempting to say that one would work, and I'll be honest, I was tempted for a second to say that one would work because all of these numbers are prime and they add up to 25. But if you just imagine this triangle for a second, if one side was 19, so imagine that's about 19, and the other sides were only 3. 3 is nothing compared to 19. These two little sides are far too short to join up to make the third point, and so 3, 3 and 19 wouldn't work. The two shorter sides of an isosceles triangle need to add up to be at least the length of the other side. So 3 plus 3 just wouldn't be long enough, so 3, 3 and 19 wouldn't work. 4 isn't a prime. 5 and 15 wouldn't work because 15 isn't a prime. However, we could have 7. So how about 7, 7 and 11? 7, 7 and 11 actually would work because 7 plus 7 is 14, plus 11 is 25. All of these are prime, and 2 7s is at least 11. So that one would be a valid combination. And so our first possibility is that we can have two sides which are 7 and another one which is 11. So let's carry on. So could we have 11 twice? Well, if we had two sides which were 11, that means the other side would be a 3. And so that, again, could work. That one would be two sides which are 11 and a very small base of 3. So that could be 3, 11, and 11. Now that could work. So again, that could be a valid second option. And so using that, we've got two different options of what the two triangles could be. Question 19. A children's nursery uses one room for babies and one room for toddlers. Each baby needs at least 3.5 square meters of floor space, and each toddler needs at least 2.5 square meters of floor space. We need to show that the total number of children allowed is larger if the toddlers are in A and the babies are in room B. And so one way we could do this is by thinking about it as a table and doing it systematically. And so what if the babies were in room A? So let's just think about the babies for a second. So it says each baby needs at least 3.5 square meters of floor space. And so if the babies are in A, then the total number of babies allowed would be the total space in floor A, which should be 40, divided by the space needed for each baby. So 40 divided by 3.5 would be 11.4 something. So not quite enough for 12 babies. So the calculation we did was 40 divided by 3.5, which was roughly 11.4. And that tells us we could have 11 babies. 11 and a bit, so not room for 12, but plenty of room for 11. Now if the babies are in room A, that would have to mean the toddlers are in room B. So in room B, we've got 37 square meters of floor space, and we're told that toddlers need at least 2.5 square meters of floor space between them. And so the number of toddlers we could fit into room B would be 37 divided by 2.5. So how many toddlers can fit in? Be 37 divided by 2.5, which should be 14.8. So 14.8 toddlers was not enough for 15. what that says is there could be 15 toddlers. And so if the babies are in room A and toddlers are in room B, 11 plus 15, that gives a total of 25. So one option here is babies in room A, toddlers in room B. That's a total number of people, of children. 11 plus 14, which should be 25. Now the other option is if the babies are in room B and the toddlers are in room A. So the second option I've highlighted in red. The first option we've done I've highlighted in this aqua colour. And so if the toddlers were in room A, toddlers need 2.5 square metres of floor space. So in room A there's 40 square metres. If we divide that by 2.5, what you would see is that would be exactly 16. So we could fit exactly 16 toddlers in with no wasted space whatsoever, no spare space, exactly 16 toddlers. And if the babies were in room B, again room B, we've got 37 square metres of floor space. So divide that by 3.5, because each baby needs 3.5 square metres. And what we'd get for this one would be 10.5-ish. To one decimal place, that'd be 10.6. So that'd be 10 babies in total. Not quite enough space for 11 babies. And so the second option, if the toddlers are in A and the babies are in B, then that would come to a total of 10 plus 16, which should be 26 children. 26 is more than 25, albeit by 1, and so this working proves that the space is maximised if we had toddlers in room A and the babies in room B. We can get one extra child in total if we do it this way round, instead of having the babies in A and the toddlers in room B. Question 20. We need to work out the next term of a quadratic sequence. A quadratic sequence is where the gaps between each number are going up by a fixed rate each time. So between 4 and 12, that's an increase of 8. Between 12 and 24, that's an increase of 12. And from 24 up to 40, it's got 16 bigger. So let's focus on the gaps. First one's a gap of 8, then a gap of 12, then a gap of 16. The gaps are increasing by 4 each time. So with an arithmetic sequence, like the nth term, the gaps are always the same. With a quadratic sequence, it's the gaps of the gaps which are the same. And so the difference between the gaps each time is 4. The gaps are growing by 4 each time. So 8, 12, 16. The next gap will be 20 because it's getting 4 bigger each time. And so from 40, add on 20. The next number in this quadratic sequence would be 60. And that's it. Plus 8, plus 12, plus 16, next one plus 20. 40 plus 20 is 60. Question 21. Circle the inequality shown by the diagram. So an inequality means it's going to involve inequality symbols, as we've got here anyway. So the key thing to notice is which numbers x may be between. And so what we do is put a note of what numbers these circles are above. So -7 and 6. So this means that x is somewhere between these two. So that doesn't help because -7 and 6 are in all of the possible options. What we're looking at to solve it is if the circle is filled in or not. Now, a filled in circle means x can be bigger or equal to that number. And so a filled in blob means one of those symbols. And so it could be either the second or fourth options. On the other hand, if a circle isn't filled in, it means x can be all the way up to that value, but can't actually be exactly that value itself. And so that means x must be less than 6. X can't actually be equal to 6. And so what we're after for that one is a symbol without the line underneath. And so it's got to be this one here. So x can be -7 or bigger, and it can be all the way up to 6, but must be less than 6. Now the way I remembered it when I was doing these was think about which takes more ink, a hollow circle or a filled in circle. What takes a printer more ink to print, a filled in circle or a hollow circle? Obviously the filled in circle takes more ink, and then think also which takes more ink to print, one of these symbols or a symbol without the line underneath. Obviously the ones with a line underneath take more ink, and so more ink relates to the blob with more ink. The ones without the line, less ink relates to the circle that would take less ink to fill in. And so it would be this one here anyway. Question 22. Water is poured into a glass for 4 seconds. The graph shows the depth of the water in the glass. And we're asked what is the rate of change of the depth of the water, and we need to circle the answer. And so look at the units. These units mean centimetres per second. So we need to work out how much it's being filled up by in 1 second. And so what we can do, we could work out the gradient of a graph. That's one thing we do, how steep it is. What I'm going to suggest we do is we just take one point on the graph, maybe this point here. So this point here is 10 centimetres. So this is one where it went and filled 10 centimetres, and it took 4 seconds. So this means that the glass gets filled up to 10 centimetres and it takes 4 seconds. So what we can do is from this work out how much it's filled up in per second. And so to go from 4 seconds to just 1 second, what would we divide by? The answer is we could divide by 4. Any number divided by itself gives us 1. And so if we divide by 4, that will tell us how much it fills up in 1 second. So if we divide the seconds by 4, we need to divide the depth by 4 as well. And 10 divided by 4, that would give us 2.5 centimetres. 2.5 centimetres in 1 second. That's another way of saying it's 2.5 centimetres per second. And so what we need to do now is circle this option here. Question 23. We have an ordinary dice, and part A, Ali is going to throw the dice 6 times, and he says, I will get 1 of each number. And we have to give a reason why he could be wrong. It seems almost intuitively obvious that he's going to be wrong. It's just a case of how to explain it as clearly as we can. There's a few things we could say. I think the most obvious one, in my mind, the most obvious explanation is a reason he could be wrong, is to say it is possible that he could roll the same number more than once. We just don't know. There's that random chance element. He could roll 2 1s or 2 6s. For all we know, he could roll 3 6s. We just don't know. But it's a case of getting the wording down in a way which is clear enough to the examiner. And so I think that explanation is absolutely fine. It's possible that he could roll the same number more than once. This whole thing about probability, you just don't know for definite. So that's what I'd say for part A. Part B, Lucy throws the same dice 50 times. We've got a table showing her results. We need to work out the relative frequency of throwing an odd number. And so an odd number is going to be a 1, 3, or 5. The even numbers on the dice are 2, 4, and 6. And so the odd numbers are 1, 3, and 5. Now this relative frequency business, that's just a fancy way of saying we need to write normally as a fraction how many times in this case odd numbers were rolled out of the total number of trials. In this case, total number of dice rolls. And so the odd numbers, how many times were odd numbers rolled? Well, 1 was rolled 7 times, a 3 was rolled 12 times, and she rolled a 5 9 times. And so from this table of values, that's 7 plus 12 plus 9. So it's a total of 28. 28 odd numbers were rolled. How many times does she throw the dice now? It says it was thrown 28 times. So what we can say there is 28 out of 50 throws were odd numbers. She threw it 50 times, 28 of which gave her an odd number. And so if 28 out of 50 were odd, we can just put that into a fraction by saying it's 28 over 50. Now, whatever comes after the word of goes at the bottom of the fraction. Whatever comes first goes at the top. And so we can write this down as 28 over 50, and if you really want to, that can be simplified. Now with probability, you don't need to stress about simplifying things down as much, but if you wanted to, by all means, you're not going to be penalised. 28 over 50 would be the same as 14 over 25. So we can put either answer on our answer line, either 28 over 50 or 14 over 25. Both would be fine. Question 24. The polygon's divided into triangles, and we're asked to use the triangles to work out the sum of the interior angles of polygon A, B, C, D, E. You must show your working. The main thing we need to remember here, the angle fact about triangles, is that angles inside a triangle always add up to 180 degrees. That's the main piece of information we need for this question. And so this diagram is a five-sided shape. And in fact, we can imagine any shape at all, any polygon, we can imagine as a number of triangles glued together. So I'm just going to very roughly just colour these ones in. So we can think of a five-sided shape as being three triangles just glued together. So we've got a yellow triangle, a green one, and also we'll have one in the corner. The last triangle, I think I'll use a blue colour for, why not? Main thing I'm getting at is we can think about the shape, we can imagine it as being three triangles glued together. Just returning to what I said earlier, angles in a triangle add up to 180 degrees. The rest of it now is quite straightforward. Each one of these triangles I've coloured in will have 180 degrees inside it. And so the question here is asking the sum of the interior angles, the sum of the inside angles for this whole shape. So because the shape can be thought of as three of these triangles, the total interior angle is 180 for the first triangle, plus 180 for the second, finally plus 180 for the third. That's all it is. Or you could just say 180 multiplied by 3. So 180 plus 180 plus 180, or 180 multiplied by 3, your calculator will nicely and politely tell you that it's 540. So the total of the interior angles would be 540 degrees. That's all we need to do for question 24. Question 25, we have a graph a parabola, it's called technically. What we need to do first of all is to circle the coordinates of the turning point of a curve. So I need to explain what turning point means. A turning point of a curve, you might be able to guess what it means in fact. It's where it changes direction. So if I look here, the graph's going up, going up, going up, and then at the top it changes and starts going down. And so the turning point is this point here where it changes direction. And so if we just have a look at that point here and get the coordinates of it, it changes direction when x is 2 and when y is 16. So the coordinates of the turning point are 2, 16. Part B, circle the value of a. So if we have a look at the equation, y equals a plus bx minus x squared, we want to work out just a on its own, so we're not interested in anything else apart from a. And so the x's, we just want to not be there. We don't want to look at the x's at all. So how can we make the x's disappear? What value could we take for x so that x just isn't an issue at all, so we can focus on y equals a? The trick here is to take the value of x being 0. If x were 0, then b times x means b times 0, which is just nothing. And x squared just means 0 squared, which again is 0. So if we just choose x to be 0, what will happen here is we'll just be left with y equals a. And so just as I've said, if we choose x to be 0, we just highlight the bit on the graph where x is 0. Here, x is 7, 6, 5, 4, 3, 2, 1. X is 0 all the way up and down the y-axis. And so the line x equals 0 is actually the same thing as saying it's the y-axis. So the value of a just means the value where this curve cuts the x-axis, which we can see here is at 12. So the value of a has got to be 12. For part C, if we look here, this equation here is the same as what y is. So if I just show you this, what we're asked is to find the roots of when this equals 0. But this equation here, you should be able to just spot. That's the same as our equation for y. And so if this a plus bx minus x squared equals y, and we're asked when does it also equal 0, this is just a fancy, complicated way of saying when does this green curve, when does y equal 0? And so it's just a case of whereabouts does this curve, this green curve I'm going to colour it in, where does it cross the x-axis? Whereabouts is this curve 0? So y is 0 along here. And so the two values where it crosses at 0, y equals 0, are minus 2 and 6. These are the values of x where y is 0. So the roots of the equation is just a fancy way of saying what values of x make the equation equal to 0. So the two values of x are -2 and 6, because this is where the curve crosses the x-axis. So the final thing we need to do is just circle one which is -2 and 6. And that's question 25 done. Question 26, a school, 60% of the students are girls. I'm told some percentage of girls walk to school, some percentage of boys walk. What percentage of the students walk to school? What makes this a weird question, quite a complicated one potentially, is that we're not told how many students there is. So 60% of what? 50% of what? What I'd suggest we do for this one is to make up a number. And make up a nice number so it's easy enough to calculate with. Well, percentage means out of 100, so maybe we could just say the total number of students was 100. Let the total number of students be 100. Hundred is a nice round even number, so we can make up any number and base our calculations on that number. So let's say the total students was 100. In that case, if it says that 60% of the students are girls, then that would mean for our made up number that 60% of 100 students are girls. If we worked this one out, that would mean there's 60 girls in total. So we've got 60 girls. It then says 50% of the girls walk to school. So based on our made up number of 100, if 50% of the girls walk to school, that means 50% of these 60 girls would walk to school. So 50% of 60, you might be able to see straight away that 50% just means half. Half of 60 would be 30. But if you just want to be reassured by your calculator, by all means, 50% of 60 gives us 30. So that says that 30 girls walk. So we worked out 50% of the number of girls, 50% of 60, and we've got here that 50% of 60 is 30 girls walking. And now it says about the boys. Well, if 60% of students are girls, what that must mean is the other 40% will be boys. So 40% of the students are boys. And so, if there's 100 students in total, the number of boys will be 40% of 100. So that means there'd be 40 boys. If there's 40 boys, 60 girls, that adds up to 100 like it should. So we've got 40 boys. And now 20% of those boys walk to school. And so 20% of 40 would tell us how many of those boys walk into school. So 20% of 40 brings us to 8. So that means that 8 boys walk. The question's asking us for the percentage of students that walk to school. So that means girls and boys combined. So if 30 girls walk, and also 8 boys walk, that tells us that the grand total number of walking students is 30 plus 8, means 38 students walk to school. So if 38 students walk, that means 38 out of 100 students walk. And 38 out of 100, by its definition, is the same thing as saying it's 38%. And so our final answer for question 26 is that the percentage of walking students is 38%. 27. We need to factorise fully 9a squared minus 6a. The examiner's actually been quite nice here by saying factorise fully. Factorise fully means, or usually means, there's going to be 2 or more things we can factorise out. So the way we need to factorise is, first of all, we've got 9a squared, so the first number is a 9, the second number is a 6. And so we need to think about what's the biggest number we can divide into 9 and divide into 6. Well, the answer to that would be 3, because 3 fits into both 9 and 6. The second thing which is common to each group of things, common to the 9a squared and the 6a, is the letter A. And so because there's an A in each, we can also factorise out an A. So fully factorised, it wouldn't just be a 3 or be an A, it'd be the 3 from the numbers and an A from the letters. Once we've factorised out and found everything which is common in each group, that's when we open up the brackets and compare what we have on the outside to what we want to end up with at the end. So looking at the number, we've got a 3 here, we want to end up with a 9. So what do we multiply 3 by to get 9? The answer is we multiply it by 3. 3 times 3 gives us the 9 that we want. At the minute, we've got an A. For the first thing, we want to end up with A squared. What does A squared mean? It means A multiplied by A. So if we've got an A on the outside, we need an extra A on the inside to generate the A times A to give us the A squared. Now we can move on to the next thing. We've got a minus sign in between, so just dump in a minus sign here. And compare the numbers again first. We've got 3, we want to end up with 6. So what do we need to multiply 3 by to get 6? The answer would be 2. Then look at the letters. We've already got A, we want to end up with A. So we don't want A squared or anything, the A's already sorted. We don't want to change the A, so don't put any extra A's on the inside. So the fully factorised answer is 3A brackets 3A minus 2. And you can always double check your factorising, because if you expand it, you should get back to what you had to begin with. And so this one is 3A brackets 3A minus 2. Part B, we need to factorise this here quadratic. So what I'm going to say first of all is we can ignore the equals 0 at first. So let's just focus on factorising into brackets this expression here. Now the way we do this is we need to think of a pair of numbers. We need to think of 2 numbers that multiply to give the number at the end, which is positive 20. And the same numbers, when we add them together, they need to give us number in front of the x, which in this case is minus 12. Now importantly, if we add numbers together and we get a minus answer, we know for definite that at least one number must be a negative. If you only add positive numbers together, the answer is always going to be positive. So at least one of the numbers is going to be negative. But looking at what happens when we multiply them together, one number multiplied by the other gives us positive 20. The only way we can multiply numbers together and get a positive result is if both numbers are positive, which can't be the case here because at least one's negative. So either both are positive or both must be negative. So because at least one's negative, that means that the other one must also be negative. So both numbers we're trying to find must be negatives. So first of all, we can start with thinking of two numbers that multiply together to give 20. So we could try, for example, minus 5 and minus 4. That would work. Minus 5 times minus 4 gives us 20. But minus 5 and minus 4 would only give us minus 9. If we take away 5 and then take away another 4, it's the same as only taking away 9. And so minus 5 and minus 4. We had a go, but that didn't work. But never mind, we can try some other numbers. Eventually, what you'd hopefully stumble upon is that minus 10 and minus 2 work perfectly. Minus 10 multiplied by minus 2 is minus 20. Sorry, positive 20. But minus 10 plus minus 2 gives us minus 12. Now, I do know that negative numbers can be confusing, but with a calculator paper, we can just double check if we want. Minus 10 plus minus 2 equals minus 12. Great. And so it just makes the number crunching aspect much quicker and easier. So we can use the calculator to help us. At any rate, what we've done is we've found the numbers that work. The two numbers that solve the problem are minus 10 and minus 2. And so what we next do is we put two sets of brackets. Because it's x squared we're talking about, we have an x at the beginning of each. And then in any order, the numbers we've just found go after the x. So minus 10 and minus 2. And then we've fully factorised it. But of course, there is a slight snag. That wasn't the only question. I mean, this will give us some marks and some credit for doing this. We needed to find when this is equal to 0. So we can still do it. If you've got two brackets next to each other, it means one bracket's multiplying the other. So if you just think of it like here, that means bracket 1 times bracket 2 equals 0. If you multiply two things together and the answer's 0, you should know for definite that either the first thing has got to be 0 or the second thing has got to be 0. So because we're multiplying these brackets together and the answer needs to be 0, at least one of these brackets has to be 0. So option 1, maybe this first bracket is equal to 0. So maybe x minus 10 equals 0. Or the second bracket, x minus 2 equals 0. So these are now just one-step equations. We want to have x on its own. So we want to get rid of that minus 10, swap it to the other side, and swap its sign to a plus. Same deal for this minus 2. Swap side, swap sign to a plus. And what that would give us is that x minus 10 equals 0 only when x equals 10. Or if the second bracket's equal to 0 and x minus 2 is equal to 0, that tells us that x must be 2. So the two possible solutions are that x equals 10 or x equals 2. That's our final answer. The quick trick when you've factorised into brackets like we have here, by the way, the solution will just be these numbers with the signs reversed. So minus 10 and minus 2 becomes positive 10, positive 2. If this were x plus 10, our solution would be x equals minus 10. So that's a quick trick, but I've just tried to explain why the answer is x equals 10 or x equals 2. Question 28. We've got Adam running a race with 6 other men. And the times in seconds are recorded below. It says the mean time for all 7 men was 9.83 seconds. Did he win the race? So we've got the 6 men here. What I'm going to do is include Adam's time here. So we need to find what A is, what Adam's time would be. It mentions the mean, so how do we calculate the mean? The mean time would be the total of all times divided by the number of times we've just added together. So let's have a look which bits of this equation for the mean we can fill in. So the mean, are we told what the mean is? We're told the mean is 9.83 seconds. So 9.83 equals the total of all times. Well, we're not really told the total of all times because we don't know what Adam's time is. But we do know the total of these times because we can just add them together. So for all these times here, the 6 which we have been given, we can do the total of these easily enough with a calculator. So the total of those times is 9.75 plus 9.79 plus 9.80 plus 9.88 plus 9.94 plus 9.98. And in seconds, that gives us 59.14. That's 59.14 seconds. But of course, there's also Adam as well. So the total of all times would be 59.14 plus whatever Adam's time is. And the total number of times, including Adam's time, is 1, 2, 3, 4, 5, 6, 7. In fact, it does say the total number of times is 7, because it's 7 different men. So the total of all times is going to be 7. So what we need to do here is to either rearrange this equation to find out what Adam's time is, or use a flow diagram method to solve what Adam's time must be. So I'm going to do this one of 2 ways. So I'm just going to copy this equation down here. So this whole thing on the top of the 7 is being divided by the 7. And so if we just move this 7 along to the other side, let's get rid of that thing at the bottom. That thing you just seen doesn't relate, so let's clear that away. So if we swap the side, we'd swap the sign. And so that means that the top would equal 9.83 times 7. So let's try that now. 9.83 times 7, which is 68.81. But we want to work out what Adam's time is on its own, so we can get rid of this 59.14 again by swapping its side and swapping the sign. In the same way that dividing by 7 became a multiply, this 59.14 we're going to subtract. And so A will equal 68.81 minus 59.14, which gives us 9.67 seconds. So Adam's time was 9.67 seconds. Did he win the race? Yes, he did, because 9.67 seconds is the smallest time of all these. So 9.67 seconds would be a winning time. Now, as I did say, I'll show you a different way of solving this equation, because this way I'm going to show you now is quite popular. And this is a flowchart diagram method. So the way we solve it using a flowchart is we start with the thing we want to work out. So start with A, because you want to find out Adam's time, and just take it step by step, what happens to A. So the first thing that happens to A is we add 59.14 to it. After 59.14 is added, we divide by 7. After dividing by 7, we find it's equal to 9.83. Now what we do is we start at the other end and work backwards. So we're going to go now the opposite way, and we're going to do the opposite thing each time. So if we look above, when we were going from left to right, we divided by 7. Opposite of dividing by 7 is to multiply by 7. So just looking here, so 9.83 times 7 would be 68.81. But instead of adding 59.14, we're going to take away 59.14. So 68.81 take away 59.14 would again get us to 9.67. So a different method I'm just showing you there, but a common and well-liked method nonetheless. So again, we'd see that Adam's time is 9.67 seconds, which would be a winning time. Question 29, we have a square and we're asked to work out the length of one side of the square. With a square, each side of a square is the same length, and so this top side, which is 7x minus 3, will be the same as this side. Because remember, all sides of a square of the same length. So what we can do with this bit here is expand the brackets. So multiplying it out, 3 multiplied by x is 3x, and 3 multiplied by 1 is 3. Now we've got x's on both sides of the equation. What we need to do is to have all the x's together on one side and the units together on the other side. So take away the smallest number of x's, which in this case 3x is smaller than 7x. So bring these 3x's over to the 7x, but if they swap sides, we swap signs. So we're going to take 3x's off. What we're actually doing is subtracting 3x from both sides so that they'll vanish from the right hand side. That's what's actually happening. So 7x take away 3x, we'd have 4x on this side, minus 3. On the right hand side, we're just going to be left with 3. We don't want that minus 3, so again we can swap the side of it and swap the sign. Opposite of minus is plus, and so on the other side we'll have 4x equals 3 plus 3, which is 6. The final step, we don't want 4x's, we want just 1x. That 4 is multiplying the x. Opposite of multiplying by 4 is dividing by 4. So if we swap the side of that 4, we'll swap it to a divide. So what we'll have then is the answer that x equals 1.5. But of course, we need to work out the length of one side of the square. We don't want to work out what x is. Well, we do, but the final question is working out what one side of a square is. So pick a side, pick any side. I'm going to go for this one. So now we know that x is 1.5. We can substitute in 1.5 into here. Work out the brackets first. 1.5 plus 1 is 2.5. And there's no instruction in between the 3 and the bracket. So that means multiply. So 3 times 2.5 would be 7.5. The beauty of a calculator paper is we could just do this easily. So 3 brackets x plus 1 means 1.5 plus 1, because x is 1.5, close brackets, press equals 7.5. So the final answer is that each side of the square must be 7.5 centimetres. And that's question 29 completed. Question 30. The very last question. So in the diagram, it says that DC is parallel to AB. So this is also shown by the fact that the line DC and AB have an arrow on them. Arrows on an exam indicate that two lines are parallel. We need to show that triangle ABD is isosceles. So you need to remember what an isosceles triangle actually means. Well, if a triangle is isosceles, all that means is that two sides are the same and two angles are equal. So to prove that a triangle is isosceles, we can either prove or show that two sides are equal, or we can prove that two angles are equal. We can do either. If you show that two sides of a triangle are equal, or that two angles, it's got to be isosceles. That's one of the defining characteristics of a triangle being isosceles. So what we need to do first of all is work out what we don't know. So if I have a look at this top triangle, this is 100 and that's 52. So surely we can work out this one here, the angle at D. CDB is that one. So the angle CDB, remember angles in a triangle add up to 180. And so CDB will be 180, take away these other two. So 180, take away 100, take away 52, which would leave us with 28 degrees. Now what we need to be remembering is angle facts. So co-interior angles and alternate and things like that. What we need to spot here is that because DC and AB are parallel, we can make a Z angle involving them. And so a Z angle, if you've got two sides which are parallel and a straight line joining these two parallel sides, the corners in between the Z, the corners of the Z will have to be equal. So if this is 28, this angle down here is also 28. So this angle at B is ABD. So to show our working, we can say that the angle at B, angle ABD, is always the middle letter where the angle's at. So ABD is the same as the angle we've just worked out, angle CDB, which equals 28 degrees. And the reason for that, Z angles are called alternate angles. So we can say that alternate angles are equal. Now we know that, we can finally work out this angle here at the top. Now this one is the angle ADB. So again, with this bottom triangle, we now know two angles. We can work out the third by doing 180, subtract 124, subtract 28. So if we try this out, 180 minus 124 minus 28, we get 28 degrees. So what we've shown now is that triangle ADB has got two angles which are exactly the same. So we've got it, we've done it. Therefore, ABD is isosceles because it has exactly two angles the same. Not three. If it had three angles the same, it would be an equilateral triangle, which is what we don't want to prove. So if the two angles are the same, the angle ADB and the angle ABD, both of those are of course 28 degrees. And we've proved it. So that's our proof up here. And we've finished the paper now. So I hope you found that question useful, or at least some of the questions. Keep revising, keep working hard, keep attending your lessons, and never give up. And you'll do well in the exams, I'm sure. Okay, thank you very much.